Check, check. Vossi, hey, how's it going? Right at the beginning. Hope you're alright. Alright. So today, just going to do a little bit of work on speeding up pathfinding. Potentially putting pathfinding into some kind of multi-threaded background system thing. Eventually the pathfinding will end up happening on background threads. It doesn't happen at the moment. At least solving for the paths. So we're going to work a little bit on speeding it up. Right now, if I just start the game up, it's particularly this star here. It's in Get Neighbors, where I think we can begin speeding it up. It's when you don't provide a search space, and it might end up searching basically out of the level bounds, which we don't want it to do, which will obviously take a long time, because it's going to go all the way off searching paths all the way over here or over here, when really it just needs to search for paths in the boundary of the level. Right then, let's just, oops, not that. Let's just start VSync. Go back down 60 frames. And then we also want to probably go to, whoops, where the combat is, because that's solving for paths all the time. Not with Sven though, with Hero. So this is actually in a release build. It's interesting to see what kind of time it takes. Oh, look, we've got some kind of crash. Ah, this is another thing, yes. For release builds, this type of static initializer stuff doesn't work. We'll worry about that later though. I'm not really bothered about release build at the moment. Vossi, I'm doing fine, thank you. Just started. Hope you're doing alright, nice and early. So the combat start controller is these enum arrays. For ENPCID combat stats. We need an initialize really. Do we have an initialize? We don't. So first we'll just put an initialize here to stop that crash. Resharper. Ah, cool, yeah. Feeling sharper, sorry. The elite code C. Yeah, nice one. I had a look at it. It's cool, isn't it? Okay. Combat stats controller now. Yeah, I had a look at the GitHub for it. So we need to basically run this in the initialize function. So we initialize the game state. We'll just do get combat stats controller dot initialize there like that. Yeah, brilliant. Better at test-driven development. Yeah, okay. Yeah. Okay, so this needs to know about the combat stats controller. Yeah, it seems cool. Really good for practice. Okay, so let's just run this and check that putting this in the initialize here. Putting this in the initialize here is not going to cause any problems. Okay, so let's just go back to where the combat is. Seems fine. As long as I can get poisoned and stuff. Yeah. Alright, cool. So we're getting these timer ticks down here, which is the pathfinding solution for the spiding in combat. It's most of the time fine, apart from occasionally it'll go off and do like take 5 milliseconds, 3 milliseconds, and that's obviously way too slow. So let's try and sort that out. Come with a bit of a plan, start thinking of good tests. Yeah. Should write tests that will fail. Write tests that will actually fail rather than tests, people write tests just to, like, I don't know, do something trivial that will never fail ever. Try and write tests to fail, if that makes sense. I'm going to write a test that adds two numbers together and make sure it's the right number. And it's like, that's never going to fail. Okay, yeah. Yeah. Yeah, I mean, assuming it's going to pass. If it fails, assuming you're going to... it might fail because of a syntax error or some kind of bug. Then once you get the bug out and it starts passing, you could leave that test in maybe. Okay, so this is for some reason crashing in release. Unfortunately, we don't have many debug symbols in release. Combat stat, which is E attribute type. So it's just a num array really. I wonder if this enum array is not good. Okay, I'm going to write a note for that. I don't want to get bogged down on that today. And we'll come and fix that later. Bugs. Crashes in release build with combat stats controller enum array. That is to do with some dynamic initializer thing, I'm sure it is. Use test reveal or not? I've used. So I have done a little bit of it. So this libbm library has a solution, Visual Studio solution, which has got a bunch of tests in it, which tests things like tests the image compression and everything. Tests a bunch of stuff really. And I use that for developing libbm, but I don't do it now. I don't really run the tests now. It was just, while I was trying, because I have like an image compression framework, and then you could put in different types of compressors. So I had a test just when if you want to add a new compressor, you could run the test, or any kind of image transform really. You can run the test just to make sure that the new compressor is doing what you want. And I was doing that while I was adding in new image compressions and new image generators and things like that. And then I had a bunch of other tests for like when I was writing the heap and everything. But all that I've been using for quite a long time now, and it seems fine. So I've stopped doing the tests. Okay, so what I'm going to do is in game config, we're just going to go straight to the combat room. Don't think we need this first level anymore. Okay, so we do need the first level. Might just take that out because we can derive the level now from the room. Did that yesterday. So I'm just going to have a look for where this is loaded in. Launch state level. Ooh. So we might actually change this to a game location. So And this is launch state location.room. It was written after the production code. Maybe get the level off from the room. Yeah, that's right. Yeah, that's what I'm doing. They were written at the same time as I was developing the library. And the tests are still there. So I could go back, and if I wanted to add a new kind of like, I don't know, image compressor in the future, I could run them tests. But I don't think I'm going to have any more image compressors in the engine now. I can compress any which way I want at the moment now, really, for GPUs, I mean. Maybe if I convert to like Vulkan and it has a specific image format that's really good, then board contents path. How do we do this? So level.get, that's the level path. So this is location equals board contents. No, we can just say location.room. Yeah, so if I ever want to add a new image compressor, or it's back buffer format. Yeah, for HDR. Yeah, so it'll take some kind of HDR version of an image. So if I ever wanted to do HDR, maybe I could do something like that. I don't do HDR at the moment. I don't have much dynamic range, you know, like in this game. You could imagine like landing on an asteroid and it's incredibly bright. So it's facing the sun or a star. And then you walk out of the spaceport, and then you could have a dynamic range transition or something there, maybe. Something like that. I have to look into other 2D games that have done it. For 2D, it should be supported. Definitely for 3D, I would say. Definitely for 3D games. Where the lighting is calculated, you know, like, think about 2D, the lighting's drawn in. It's drawn in. And then there might be a little bit of, like, created light. But not I don't know if enough to warrant dynamic range. I mean, maybe. I'll have to look and see if any other games have got 2D HDR. That is real, true, drawn 2D. You know, it's not meshes. Like, I have written some HDR stuff in the past. But it's great for when calculating like an exposure and things like that. When you're doing like physically based rendering techniques. Because then you can store, like, you can say your sun is this bright, and you can store a really bright value in the texture or whatever. And then you can actually expose down or up to those ranges, and it looks awesome. So this is location get level. There is a little bit of light calculation in this engine. I could support high dynamic lights. The thing is it'd probably, like, when you walk next to it, it'd make the rest of the level go black. You know what I mean? Because the light is so bright. You know, at least in a 3D game, you could, like, look at the sun and make the rest of the level go back, but then you can look away from the sun and the rest of the level comes back. Where are we? So that's location, room. Like, you could definitely create a 10-10-2 texture with this engine and put it in. You could do it. So you could store, like, the sun in a texture, the sun brightness. But you wouldn't, I don't think there's anything to load it in from Photoshop or anything. All right. So now let's see if we can take that room out. Game config. Get dazzled by UFO lights. Yeah. I might experiment with it, maybe. Thing is, I could very easily just fake it. Maybe. I kind of like the idea of, like, stepping out onto a really hot asteroid that's really close to a star, and you've got, like, a full dynamic range of, like, bloom and stuff, of, like, the starlight hitting the metal on something and it creating a crazy bloom. And then, like, the thing is, because you don't have depth, like, it'd be really nice to, like, see over the horizon into the black space behind the asteroid, and that could be, like, super deep black. When we start working on the actual visuals of the game, it's going to be really fun. Anyway, that seems to work now. We don't need a level anymore. So what I was going to do was, so there we've got 4 milliseconds on the pathfinding sometimes. So I think I might start, let's just actually check that this is the pathfinding that we are using. NPC patrol. The NPC is Spidey, and so this is what it's using, right, for its pathfinding. Sometimes this is taking several milliseconds. So I'm just going to, this will slow the game down a lot. Do we actually store in the A-star cell? We store its position. So I think when we're actually testing P current, We'll just draw it. Should check we can actually get the game canvas from pathfinding first. Yeah. So let's do canvas, draw quad in world. We'll say, yeah, we'll draw the quad. Draw quad in world. The quad is going to be rect float p current. Well, let's do bm cast vec to a vec2 p current position vec2 1 1. So that's the rect. The color we'll just do we'll do like 0.2 in the alpha there, white with 0.2, and int max for the z, and we'll just see. We'll just see what cells it's testing for the pathfinding. If any. Not in here. It's not testing anything in there. Which one is it then? Okay, well, hang on. Let's put that back. Did it ever get here? Here we go. Maybe we do actually want to test the neighbors. It looks like it's doing some kind of drifting behavior here. So whenever it does a pathfind, it's flashing. Because it's not pathfinding every single frame. I think it's only pathfinding okay, so maybe we do need to do something a little bit more. Let's take some stuff out. Let's take the drifty stuff out. It's not pathfinding every frame, it's just calculating a path, and then it only needs to recalculate its path under certain conditions, like the player stands in the way of the path or something, or any collidable stands in the way of the path. It needs to recalculate a new path. But let's just see if we can get it to calculate every single frame. There we go. So we can see the paths it's choosing to get to its, or the cells it's testing to get to its destination. Oh, we need to turn combat off actually. Well, see, occasionally there it's doing a huge test. So look at that massive test there. And then look at that massive. So they're the ones that are taking like milliseconds, where it's like doing a huge test of loads of the area. Seems to be in the retreat phase that is taking a while. So I'm going to turn off this one. And I'm going to turn off this one. And then it just is going to retreat. Oh, I died. Came back in a dead... Yeah, we need to actually... Came back in a dead phase. It killed me. Need to fix that. Need to reset the death. Okay, so it should always retreat now. There we go. So we can see sometimes it is testing like loads of different squares there. Okay, so the first thing we're going to do is stop it testing outside the bounds of the level. So, how do we pass in the bounds of the level? We have this thing called level nav mesh region, which has it in. I think it's calling through here though. So this NPC is the Spidian calling through here. So I'm wondering here if we pass in a bounds. So it would be const rect search area like this. And then on game state we do tick NPC patrol. Here it is. We need to pass the search area here, which is the room bounds. How do we get the room bounds? Game state. Get current room. So we have to like find room. Okay, so That's one way to do it. That's not a great way to do it though. So we're just going to put in a little dummy rectangle for now. Start. Well, that's using a nav mesh anyway, so that's wrong. It's this one. Start goal. Start goal search area. It's there. Banbjerg, hey, how's it going? Don't use Arch. What do you mean? What do you mean by that? Hope you're all right. Welcome. Right. So we need a good way of getting the current room bounds. So in game state, we do save current location. Where would it be? Here. Now I wonder if we could update that to a region, because a region. Arch Linux. All right, okay. No, I don't use Linux either. Well, I did at uni, but I don't my day-to-day life anymore. This is Windows 10, this that I'm using at the moment. Vibe learning. Alright, cool. Yeah, I did 5 years of it at uni, because that's all they used. But I wasn't a fan. I wasn't actually a fan, really. Okay. Okay. So the current location, where do we set it? Set location. So we're looking for game state set location here. Not there. Not there. There. NPC location. Okay, so what I might do is in set location, we are getting the level, calling on enter, we are getting the room, so we probably could just set the room bounds here. Two years of self-taught program experience. Oh, cool. What languages were you learning? Yeah, stuff with Linux and that is, you just got to use it for a while and you'll get used to it eventually, probably. Okay, so we're going to change the current location to a game region, and that has a rectangle in it because it's a region, not a location. And then we're not going to just rename it because I want to check that we are going to, everywhere we use this, I'm going to make sure that the region now has got the rooms bounds in it. Visual Studio, C++, yeah, cool. Yeah. Yeah, it's so big, isn't it? There's so much to it, especially if you're going to start doing CMake, other types of build systems. Yeah. C++ is a good language, though. It's what I use most of the time. Alright, so we're just going to build this, and we're going to go through all the compile errors and make sure that now we're storing the current room's bounds in the region. So the current region now would be the room we're in, and the bounds of the room we're in. Hello, we're working on Linux. Cool. Nice one. Yeah, a bit more involved than Visual Studio for sure. Visual Studio is nice because it kind of hides the build system from you for beginners, you know, when you're just learning. So you don't get overwhelmed by even just trying to build the program. You're already overwhelmed by the syntax. You don't want further problems trying to compile and link it, you know, and run it. Okay, so the current region now isn't just an empty game region. This is saved region. Nice one. Yeah. Yeah, Visual Studio's complexity comes in with the amount of debugging tools for sure. It's got a really great debugger. Yeah, nice one. Yeah, have a look at CMake. Or whatever you want, really. Okay. So this is current region.room. So there's a bunch of errors in game state with this. So we could probably just go through them all, you know. Tick animation controller. So we really want to draw it. So we've got entity location. So we have a call for this. We have now in current room AC.getID. I also do rely on some Windows only code. Need to find alternatives. Yeah. There are alternatives for all of it for sure. Or you can use, there's a lot of the STL, you know, standard library has platform independent. It's all platform independent. You could have a look in that as well. Define strategy, just practice. And I always say if you're picking a language like C or C++, I would approach it. You're picking that language because, in theory, you want to learn about the low level systems like memory and stuff like that. So I would say learn memory management and get to a point where you could build your own dynamic array in your own hash table, and learn from that. The more traditional kind of So you don't have to rely on STL. And then once you know that how it works, you can go and use STL. But you need to really still understand what's happening under the hood if you want to squeeze the most out of your programs. Quite a lot of files. Yeah. Pick something like standard array from this standard template library. Try and make it yourself, or try and create something that does the same job, so you know what it is. And I think you become a better programmer if you know how what everything is, in terms of I'm just going to use it for a language like C or C++, I would say, because that's why you're, in theory, choosing to use it for your project, because you want to know, you want the low level stuff. Once you don't depend on STL, go to C. Yeah, you can go to C. C++ and C at this point now, especially with like C++ 26 coming out, are very different languages though. They're not the same. The C/C++ idiom, or whatever you want to call it, isn't a thing anymore, I don't think. They've diverged hugely. Do have my own version of standard vector. Yeah, so make your own version of standard vector. You know, I've practiced all that. And if you want to try and write platform independent code, you could do that at the same time. If you wrote your own standard vector, you could write that straight away in a platform independent way. If you wanted to. You don't need to rely on anything Windowsy. As long as you're not allocating your own memory. As long as you call him malloc or new, you should be fine with something like standard vector. Standard vector is quite a hard one to start with. Standard array would be easier. Or something like standard optional. And it's not to say never use those containers. Don't you know, I'm not saying that. I'm just saying that, like, it means that if you're learning, when you come to use them, you know what they are, and you'll know why caching a reference out of a standard vector is a really bad idea and stuff like that. You'll know why. Yeah, the template syntax is very hard to read, unfortunately. But you just start small. Start with like one template argument. So like fixed array or standard array. It's called fixed array in my engine, but standard array. Well, it has 2 template arguments, but one of them's only the size of the array. So it's not actually really a template argument in terms of varying types. Yeah, I mean, you're always learning all the time. The learning never stops, really. You never get to the end. But that's why I love it, because it's like an endless kind of exploration. It's good. Okay, so we got get location. I'm gonna call this get region. And I'm not deliberately not just doing a flat out rename. Just because I want to see where this is used to make sure that I can set the room bounds everywhere. Yeah, like that's one of the big complaints about C++ that I hear, which is a valid complaint, is that it's really difficult to read. Like all like this type of stuff, you know. It's like that's going to scare anyone off from even trying to learn what it does. So I wish there was a better way. Now they're doing something. C++ to bring in reflection into the language, and I reckon this might change a lot of how this actually can look. Like this will still remain in the language, but in theory, you can build now just functions that reflect into the language and create these objects in more of a procedural way, which would be really nice and will help. Biggest issue DirectX and Windows alternative on Linux, something less lower level to start with for sure. Yeah, you could just use OpenGL, which is much simpler and works on Linux. Invossi, alright, see you later. See you next time. Yeah, try and use you go to OpenGL for Linux. STL, yeah. Oh yeah. Depends what you're wanting to learn. Like if you're wanting to learn how STL works, for instance. If you wanted to learn not how STL works, but if you wanted to learn how you get events from the window in Linux, how the whole creating a window and stuff works in Linux, then use the Linux one. But if you just want to get a window open to try and draw some stuff, then you can use STL. Yeah, start small, yeah. Like I would just, if you're okay with the syntax of C++, just look at how to open a window in Linux. It's probably not that bad. I've never done it before myself on Linux. On Windows it's not very bad. It's not that bad. So we're doing set location here. So the temp is the current region, right? And then we're just saying the current region is the location. So calling on enter the room if it's a new, on enter level if it's a new level, on enter room if it's a new room. But I think before we want to do all these things, we do want to actually get what room we're in. So we've got game location change, that needs to be game region change now. Yeah. A lot of people do just go straight to STL. Depends what you want to learn. Copy and paste, yeah. Yeah, you need to find out how you learn the best. What I tend to do now is I'll get samples. So a few years ago I was learning DirectX 12 now. So I got the sample pack off GitHub from Microsoft, and it had loads of samples of DirectX 12. So I just went through them and recreated them myself and used those as reference. And that's how I learned it. And did some reading and stuff like that. And then they provide an entire Microsoft provide an entire engine called the mini engine, with DirectX 12, so you can actually see a full engine with it in. Yeah, DirectX 11 is really good. I've used DirectX 11 for a long time, but yeah, I just wanted to learn DirectX 12. So that's what I did, and then I did my own test project for DirectX 12. my own test. It wasn't a game. It was like a graphics only thing, really. Just wrote some. It was to simultaneously learn DirectX 12 and to learn quite a few of the anti-aliasing techniques. So you did a little mini project with that in it. And then this engine now runs on DirectX 12, so I brought it over into this engine. Okay. So what we need is the location has a level. The location's got a room in it. So we need to do level, find room, lock.room, auto level room. Like this, and then we're going to go if that current region bounds equals level room bounds, and that will set the bounds for the current region. Rendered in DirectX 11, cool. Yeah, so if you're doing DirectX 11, you must be pretty okay with C++ then. Because that's not a beginner's library, I would say. 150 milliseconds, it's software rendered. Oh, interesting. So you've written your own software render. That's good. So this will set the bounds in the region. And game location changed event now. These need to be regions. So it's game region changed. Now. Save location. So this needs to be called save region. Save current region. Like that. And it calls MC save current region, which is probably not a call in the movement controller. Probably is called save current location on that. Save location. So it's not save current location, it's just save location. So all the movement controllers has to save their locations. So we've got set location there. So we are actually only saving the location. We only need to because we're just setting. We're just calling set location. So I'm going to say this is just called set current region. And program create context and compile the shaders and all that. Ah, right, okay, yeah. When program boots its load directory, it says sync. Uses software renderer to render the UI and then swaps implementation when ready. Oh, nice one. Yeah, nice one. That's really cool. That's a nice little project, that. So it can take a while to. I'm not sure how long it takes to launch DirectX 12 on this engine. I've got it written down somewhere, but it can take a while, especially on like lower end laptops and stuff. Yeah. How does it really? My lower end laptop definitely does it a lot slower, for sure. But yeah, I can imagine. Yeah, interesting. I wonder if it's to do with shared memory access, you know. Because obviously your integrated GPU just shares memory with RAM, with the CPU through RAM. Whereas when you've got a dedicated GPU, it has to copy it all down there. So I wonder if that's the extra performance cost right there, maybe. So we've got restore location. This is going to be restore region. This is just restore location. So do drivers. Ah, right, okay, yeah. Yeah. Yeah, that's it. Region.room. Yeah, so yeah. Software renderers, obviously you don't have enough cores to emulate properly what the GPU does. So it's a lot slower. Even though the cores themselves are a lot faster, you just don't have enough of them. Even if you have, like, say you got a 16 core machine, you could divide the screen into 16 equal parts to do the rendering. Try and emulate a GPU. The GPUs have like thousands, don't they? Current. So I'm just going to look at all these current locations. I'm going to change them to current region now. Look how slow Visual Studio is at doing that. It takes like 2 seconds to react. Meanwhile, something like Red Dead Redemption 2 has done 120 frames of rendering in that time that it's taken Visual Studio to put some characters on the screen. Yeah. Right, okay, yeah. So you're going to take your software renderer further then? Are you going to actually try and get a Z buffer sorted? That would be cool. That'd be a cool project. Possibly we'll build a nice one. Right, so we've at least got this file building. And that means now, when we do tick roaming, no, tick NPC even. Tick NPC patrol, that's what we want to do. This rect here now can be current region dot bounds, and then we can send in the room bounds to the pathfinding. Who else is doing this? No one else in this. Yeah, so we can send in current region dot bounds, and that is the pathfinding test area, which is what we're going to use. Smooth resizing, yeah. Interestingly, like smooth resizing, I found with DirectX 12, it's not smooth until you start putting quite a lot of stuff through. Don't know if that's my implementation or not, until you start rendering quite a lot of things. So it started off being quite not smooth, like rough resizing. And now it's alright. Now we're actually getting quite a lot of stuff going through. Weirdly. When is it 60 frames while resizing? Cool. I don't know what mine does. If I resize it, it has to, because with DirectX 12 you've got to actually stall the GPU to resize it. So it will definitely won't be 60 frames. You got to flush the GPU, resize all the buffers, which takes quite a long time. No, I haven't measured it though. Alright, let's keep going then. And resizing all the buffers means really destroying them and recreating them. So that's that's a lot of work in it. Let's have a look. HAL resize window. So it calls resize on a window. Then it flushes everything, which is all the queues. So in DirectX 12 you have queues, you queue things. So it flushes all the queues, right? And each flush is a signal and a wait. So that's like stalling the GPU. Well, that's like, it's not necessarily stalling the GPU, but it's definitely stalling the CPU. Because there we're waiting. This wait is a wait for single object. So it's potentially waiting 3 times there. And then it has to do release window dependent resources. Which releases all of its back buffer targets. And it's... How's it? Hang on, lost my place here. So we do resize. Release window dependent resources on the window, which releases all of its back buffer targets. And then it calls resize buffers. And then it recreates all of its window dependent resources. Again, with the new size. But it's probably mainly this flush which takes a long time. Yeah, so you can just release, so on DirectX 11 you can just do that. On DirectX 12, because it's lower level, you've actually got to do a sync with the GPU, because the GPU could be using those resources you're about to release. In DirectX 12, you've got to do all the resource management yourself, and that includes stalling until all those resources become unused, and then you can release them. If I was to just do a release here without calling flush, it would crash. The GPU would just like hang, basically. It would crash because you've just like deleted memory from underneath the GPU's nose, you know, that it might have been working on. The release function in DirectX handles the syncing. So I think the syncing, yeah, so it might do. Or it happens in, because you do have to still call resize buffers, don't you, in DirectX 11. It might happen there. I can't remember actually. But yeah, if you release it, it probably just puts it on a list of stuff to be released in the future. And then when the card's finished with it, it'll get released. That's probably how DirectX 11 does it. Yeah, exactly, yeah. Definitely, so yeah, that's true of all resources, not just resizing the window. If I was just to release the texture or a mesh or whatever, or a buffer before it's been finished on the GPU, it will crash. So yeah, the release on DirectX 11 must be releasing it a little bit later, a few frames later. So when you call release, it doesn't actually get released there in DirectX 11. Whereas I think when you call release in DirectX 12, it actually gets released there. So if you haven't synced it properly, it will crash. Long time ago. Yeah, that release code there, I wrote a long time ago. I wrote a couple of years ago now. Yeah, that. Once I get the game running again, I can run an older version of it. So this is I don't have a working debug release build. So if I resize the window, see, that's pretty nice. It's hanging because it's not hanging because I'm resizing the window. You can see it's hanging because of the pathfinding. But it does squash it a bit and stretch it a bit. It's not that smooth. It eventually gets. It eventually sorts itself out. Oh, that's a crash. Yeah, it's not very stable at the moment. I'm just working on some optimization stuff. Yeah. The random crashes. Yeah, that crash was from something else, I think. I'm right in the middle of doing some pathfinding stuff. And that would have actually, because I ran that outside the debugger then, I would have actually stopped in the code there. Otherwise, so this next location is next region. Now, is it? No, that's changing the wrong thing there. It's the E, which is not used here. Telese, how's it going? Welcome back. I'm doing alright, thanks. I'm just working through speeding up some pathfinding stuff at the moment. Get region lock. So we're just going to rename this region, not current region. I'm glad you're doing well. Car.location. So I'm just going to get region there. All right. So in the effects controller, I'm going to call this current region again. Current region. Get region. This really needs to be called get current region. There's a lot of get regions, apparently. Alright, get current region. And then we have current region.room. We only need the room out of it, really. Get current region. Get room. So we'll probably just get it out here. Auto current region equals state dot get current region. Current region dot room. All right, let's keep going then. Get location. All right, so this, all we're going to do is just want to call get current region here. Not going to pass along the region, we'll just pass along the location. So the difference between a region and a location is a point in the game and a region is an area in the game. But an area in the game can get converted into a point in the game. You just pass the middle of the area, middle of the region. So I won't forward through the entire region, I'll just forward through the actual location. So what's this? So this is lock room. So we do have a game state in current room. Game state bar.id. That depends if this looks for entity locations. Yeah, it does. That's fine. All right, let's keep going then. Save location is not a member of game state. So this is now saved region. So I need a breakpoint here to check we're actually setting the current region bounds. And that should be it. Hopefully it all works the same. But now we have our actual area to do pathfinding on, which is good. Okay. So the location to room, the combat room, the region, the bounds for the combat room is this. So I think what we want to do is we want to do current region dot position equals current region dot bounds dot center as well. And that should do that. And then in the A star file now, we have this search area. So search internal, it needs a const rect search area. Search area. This also, well, this uses the nav mesh. We'll just put a rect in there for now. And now when we're drawing here, we get the game canvas out here and do canvas, draw rect, draw quad, outline, in world, search area, the stroke, let's say pixels to world, we'll do 2 pixels stroke, float color 1:1 in max. So now we're just drawing the area. Probably put that as temporary as well. We'll just run this. We'll just build this and we'll run it and we'll see if we're actually drawing. So we need to swap. Well, it's only going to work in where NPCs are doing pathfinding in the room. So we need to go to a couple of rooms with NPCs in. And we'll just see what appears. Okay, so we have our search region now. That you can search in, so you can see how much searching he's doing outside of the region. That's causing a big stall. Search region's disappeared now though. Search area is 0. So where are we now? In the movement controller. So we want to do game state, get current region, bounds. Yes, we're calling it from a second place here. We're doing a search in a different area of the code. See that it's massively searching out of the area there. Most of the stall now is in drawing all those quads. So we don't actually want to draw this if we're in the current room. If get game state, playable character. Well, in current room we don't have the actual entity testing, I don't think. Okay, that's fine. It's only the drawing thing. I'll get deleted in a second anyway. So what we want to do now is we want to restrict. So when we call get neighbors, we want a search space. So we want const rect search space. So I wonder if we could cast it into a rect. I here. So the standard optional rect I search area. And then we don't pass it through there. We go if search area. say search. Search bounds, we'll call this one. So if search bounds.area search area equals the search bounds, else, well, we won't have it optional because we'll just test its area. Like this. And then here we're just going to go search area equals recti, like that, and we'll just reset it for this one. And now when we draw it here, we're just going to go bm cast rect to erect search area. Like that. And then when we do get neighbors now, we can test if any of these are in the search area. Else if search area, so if there is a search area, let's do this for now. So we're only adding in the name, so we want to go if search area intersect ni. Okay, so let's just see if that stops the A star searching out of the search area, out of the room bounds. So what I'm going to do to make sure, because this is a floating size area, is I might do round it and do bm cast rect I to the rounded one, so it's on a boundary. It's on a whole number boundary. Okay, we'll build this and then we'll just see. Interesting, Visual Studio is not using anything there. CPU wise. Should have, maybe it was not much to build, I don't know. There we go, it's not searching outside. Alright, it's cool. Right, so let's take the drawing off and we will see where are we? So it was taking, so it was taking sometimes 5 milliseconds to do a search. Let's just if zero this. Let's if zero this. And then let's put this cache back on. And then we're going to watch and just see if there are any spikes. It should be fairly quick now though. So let's have a look. Oh, look there, it's taking many milliseconds. 8 milliseconds. It's still taking a long time. Didn't stall the game though. And he's sometimes warping down there. That means he couldn't find a path. Most of these aren't taking any time at all. Some of them are though. All right. So let's put combat back in. Move these conditions off the nodes. Okay, so now we're not actually deducting HP, which is interesting. Can I deduct HP off him? No. It is, it's just not showing the bar. So the attribute bar thing, we did change, get the bar location. Doesn't seem to be working. So the game HUD here in current room bar ID. What that used to be. Get the entity location. If there's not a location or the room is not equal to the current room. This is a region now, so let's put this back in. Well, this is entity. No, entity location is in location. What am I doing? So we'll check this fixes it. If it fixes it, we need to actually change in current room to work with these attribute bars. And then we do need to put pathfinding on our background thread now, I think. So we will do that next. See if we can knock off HP now. Yeah, so the bar is there now. So why isn't in current room working for the bar ID? Get game state dot in current room. Entity ID. It calls get entity location, which is what this is calling. Or maybe I just had it wrong. The wrong way around. That's probably what it was. It's if it's not in the current room, we continue. Probably I said it. I was testing if it was in the current room. Okay, so we've limited the search space, so we're not doing these crazy searches. I'm gonna die. I don't have a game either. I need to make a safe game. I'm just gonna find cover now. So it seems okay. That took a millisecond. Okay, we'll put it on the background thread. So I'm going to take a 2-minute break. I'll just check in what we've done, and we'll work on putting this pathfinding stuff in the background now. It's about time, really. So some of them do take 2 milliseconds. So we need the NPCs to basically just stand and wait for their path. So let's have a look then. So most of the pathfinding is done in the movement controller. Here. Because when we're doing combat and it's giving it places for the Spidey to move, it's just setting the move target and then it's performing pathfinding here. So this is a tick all the time. And it only stops when we get towards the target. So this can straight up be put on the background. And then we need to just check. We basically just check if it's completed. Okay, we'll work on that. We'll work on that. I'm back in 2 minutes though. Get a cup of coffee first. All right then. So how do we want to do this? So we've got an A star search result. She's got an EA star result. So I think what we want is a working. And then we can just return that it's working. Now we're going to need an ID. Because we have to determine if we're working on that ID. So I think all I'm going to do for now is just pass in a U64 ID, right? We won't do it with the nav meshes at the moment. And then what we need to do is we need to make an entry, right? So struct A star search entry, an ID equals 0. And probably just like EA star results. There's not a non version. Could be a non version really. Or unknown. And anything else we kind of want in there. And then we just want an array A star search entry. Search entries. And then we'll just do static. So what do we want to do? We'll do void set A star search entry result. And then static A star result get A star search entry result. And then so we're going to go something like if auto result equals get result ID. And result is equal to EA star result working. Return the result. Else, we'll set the A star search result to working. Like that. And then we will basically run a job. Which is this. So we'll have a scope block, right? We'll do it with locks for now. What's it? Spin lock. And we will go scope block for both of these. So we're going to go operator, so bool operator U64 other ID, return ID is the other ID. We're just going to go auto index equals search entries dot find ID. Index is equal to search entries get count, we need to make one. And then we're just going to go search entries index dot result is result, like that. I'm going to go auto if auto result equals find ID. This is index of actually. Return result. So this should just be called entry. Else return undo, right? This. And then we need a job queue. So we have job queues here. DXT get job queue. So it's just called a job queue. Static job queue. A star job queue. So this actually needs starting up, this job queue. So we're gonna have void initialize pathfinding. So just gonna go job queue. What's it? A star job queue dot start thread count. Say 4 threads. Set name. Call it pathfinding. Okay, so in the game, initialize, we actually want to start the A* job queue. So initialize pathfinding. Let's call it there. See if this knows about pathfinding. It's all right. Yeah. Okay, so let's put this function right at the top. Is that going to start off 4 threads? I don't really know how many threads we want, to be honest. Okay. So this now becomes there's a bunch of copying that might need to happen here. This is only a T array as well. So the A* search entry probably needs all this stuff. Put by value in a real array, because it might take longer than a frame to do this. Both of those need to be real arrays. And that can return the search entry. Well, not there. Set A* search entry result. So we're just going to do static void. Get A* search entry. Use this for ID. Scope lock. Return. So this is an opt ref to this. Ooh. Yeah, that's fine. That's fine. Return search entries, find ID. So we set it to working and then we get the result. And then we need to copy this data over. So all these things. still set to being a reference. It's definitely not a reference. So the start is the start. Goal is the goal. The bounds is the search bounds. Collision nodes equals static collision nodes. Dynamic colliders, dynamic colliders. Check that all can be set. So this is optref star search entry. This is if standard unexpected, is it? Result. I think it's that. Okay. So we want to do set star search entry result ID to unknown there and return standard unexpected unknown. No. That's wrong. It's there, isn't it? Like that. So here's the thing. Maybe we make it something else. Struct a star search packet. Like that. That might be a bit better. So I don't think we can get it really. So we make a packet. Like this. Like this. Make a packet, and then we're going to do a star job queue run job, passing in the packet. Which is auto result, is that. So what does actually return? A star result, which is a vec2. So that means this needs a vec2 in it. Well, we could do a star result, couldn't we? Entry, add the entry in. That's unknown actually. So this is actually a star result now. So I actually need to do that. So that's standard unexpected. A star result working. So we get the result and then we do set A star search result. We need to set the ID. Packet.id result. Like this. And this is just packet dot. And then this just returns standard unexpected. Auto result equals get A star search entry result ID return result. Like this. So this is A star result actually. All right, cool. Get rid of these. What's going on here? Let's just build it properly, get some proper errors. A star results. So you cannot compare. if result dot I think it's just error. Different error. So if the result that error is working, what is the result dot has error? If we get the result, return the result error. We need to turn the result like this. Else we add a working one in. So we need to do like a result. We could empty it out. Or we could set it to be have to do error like that. Can't just compare it. So there, these are all commas. Okay, so the search space as well needs to be, and the search area really need to be part of the packet. Rect search area. So this is dot area, search area. Well, it's search bounds. We already put the actual area in. Whoops. The search space we've not put in there. We won't put in there for now. So the search area's got to go out of here. Hang on a second. Maybe I can't do it here. Yeah, so what I actually need to do is just do a star result, a star search. We need to pass in this stuff. Like this. We need to do it on here. Okay. This has to happen like that. Fanbier, alright, thanks for the follow. Good luck with your DirectX stuff. That means we can actually put in the stuff we took out a second ago. Those two things. Search area and search space can be part of A*. We need a new copy of A*. That's what we need. Okay. Like this. So what we need then is A*. And we might do something like A*, like this. Something like that. So it's A* over a certain search area. So this is just packet.search area. Search bounds like that. And then this is just called, then we just do A*.search. So we don't actually need the ID. This is better because we don't have to change the API at all. And that bot. It's just this. This just does this. To be fair, didn't even need to do that. So this search bounds here is bm cast rect recti search area around like this. No, we don't even need to do that actually. It's alright. So this is just the search area. And then when we call into a/search, that'll do the round. And that just calls set a/search result to the result, whatever the result is. All right, cool. So when we actually return the result, what do we want to do? I think if it's not equal to working, we return the result. The question is, what do we want to do once it's finished working? So we'll do the A* result. The first time it comes along, it won't be working. So it'll set it to working, and then it'll do the A* in the background. When it's finished doing A* in the background, it'll set the search result to whatever happened. So that means it'll come along here and it'll just keep returning. It will return whatever happened. We need to like reset it. So we need to do something like to unknown, you know. So we need to say if result has value, set it to unknown. So just to test this, we're just going to while true this. Basically. So it never exits. So it's just going to return working over and over again. And we need to go to the NPC, not the NPC, the NPC patrols in game state. And we need to, rather than call this, we need to call our A*search. But what we need to do first is just turn off the behavior for the Spidean. So if we go to combat behavior, just turn that off. Hopefully he just ignores me. Yeah, cool. Okay, so what I want to do here is if 0, else, and if. And what I want to do here is I want to do a star result equals a star search MC get ID, and then the rest of these. We'll put a breakpoint there. Another one. Another bunch of bots. Okay, that didn't build properly. Let's just rebuild. So this will come along, it'll do a star search, it'll get the a star search result, and it won't be a, ooh, it'll be equal to unknown, which is not equal to working. And result error is not equal to a star result unknown. It's just this. Do we want actually a manual reset or an automatic reset? This is an automatic reset, really, which we probably do want. Yeah, that's probably what we want. What's the problem here? Does not take 5 arguments. Now we want MC, get interaction bounds. So this will come along now as the Spidean. So the NPC is the Spidean. And then if we look at our threads, we've got 4 pathfinding threads now. So I'm going to go a star search, generate the dynamic colliders. So we don't have to generate the dynamic colliders all the time. So I'm going to return unknown, right? We didn't find it. So we're going to set one. So I'll add one in. Then I'm going to set the result to working. Then we're going to run a job on a different thread, which is just going to basically run forever. And the next time we come along, we'll see it's working. Oh. Maybe that's an OR. Nope, it's not that. If the result is not working, and it's equal to working and not equal to unknown. So it's the result that has value, or or result error is equal to working. Let's try that. Something like that. Okay. So let me do that. Second time I come around, return working. So we're basically now just going to return working all the time. So I wonder if we have to return working here. Return standard unexpected A star result working. Okay. So we're going to pack it in, and then we're eventually going to have a value, which is 0 minus 1. Return the result. So let's just see how this looks. It's stuck at working there. at goal. Ah, right. And it's not working. What happens if it is equal to working? Well, let's break this up a bit. We'll go if auto result, then we go if result that has value. Do that. And we return the result. If the result is equal to working, then we just return the result. If the result.error is not equal to unknown, then we set it to unknown and return the result. So if the result has a value, we set it to unknown, return the result. If the result is working, we return the result. If the result is not unknown, so that can be our results. The error is not equal to unknown. So if it's not working and it's not unknown, we set it to unknown. If it has value or it's not working and it's not unknown, we set it to unknown. If it's working, we just return the result. Okay, so let's just put the while true back in here again. time it comes around. It's just this. Okay. So let's remove this while true. Okay. So it's not playing the animations. It's working, it's just not playing the animations now, and that's because it's needing to go in a background thread to do its drift. Okay, so the A* search does some stuff, you see. It does some... like this stuff needs to happen. And if this stuff... where are we? This stuff needs to happen. And if this stuff can't happen, it needs to do the full search. So this needs to be broken into two parts. So we need search internal. We also need so we need A* result drift. And it only needs a dynamic colliders. So I'm just going to call this try drifting, something like that. And so try drifting. It's just this bit. So it's returning like something there. It's like A* result. So I think basically this can do this. But there, we'll do that. So we'll go if auto result is try drifting. Return result. And then this can get if zeroed out. For now. I'm just going to see if this has the same behavior. So put this one back in for now. Hash. What is hash? Hash is the hash of the dynamic colliders. That can actually go here now. And we'll put that up there. Dyne collider nodes. Oh, look. So we're going to need to Okay, so the dynamic collider nodes. This needs to be TRAU32 really. Whoops. Dyne collider nodes. And we need to know this dmin thing as well. So let's just do this. We're doing it twice, but we will work on that in a bit. Okay. So we're trying to separate the synchronous bit from the asynchronous bit. The bit that we can run on one thread. First, this bit we need to run in the background. So check it still works like this. So standard, unexpected. EA star result unknown. So we were doing this thing. What is that? If there's no target index. If target index. So I think that's fine. That's because it couldn't build up a path to go to. Okay. This is constantly running pathfinding though. So it returns at goal. Man, I need to get rid of this standard unexpected thing. If it returns at goal, so I think we need to do so that tests if it's at the goal or not. So we want result dot has value or result dot error is unknown. Is not unknown. There we go. I want to try and get it to walk around me. So let's go to where Jenny is, because that's a bit easy with her. She's over in the test room. As long as she doesn't go straight off onto the monorail. Oh. Right. I'm kind of convinced that's working. So return at goal there. So we keep it, return at goal, right? So now I have it split up into two separate bits. We've got try drifting and search internal, right? So I think what we want to do is get rid of this. And then the A star search here. We need to do, I think, the drifting phase here. So that's A star. Oh, so, okay. We don't have the A star. So I wonder if we can put the A star in the entry. So what does try drifting need? It needs the path. I think that's the only thing it needs from A star. And what is the path? It's an array of vec2, right? So we could do in the entry array vec2 path like this. So we want set entry result, another one with standard span vec2 path like that. So it's just search entries index.path equals path, like that. And then this is just a star get path. And then when we do try drifting, we supply the path. Like that. And this is no longer a member of A star. I think we have everything we need now. So we need to get the path from the ID. So we need it. What's the path take? So it's an array back to get A star search entry path. Maybe make it opt_ref. Right. Effect 2 like that. And that returns the entry path. That doesn't really need to be scope locked. And that doesn't either. It's only the set that does. I think. Well, the set kind of does maybe add it in. We'll put scope locks on all of them for now. So if auto path equals get A star search entry path, the ID, we'll try drifting on that path. If we can't, If we can drift, we return. Alright, so now let's swap back over to this one. Goal hash. We don't have the goal hash. So is the goal hash something that's in a star as well? Yes. And the dynamic collision hash as well. Right. Okay, I'm just going to take 2 minutes to go to the loo, and then we'll keep working on this. Alright, I'm back. So we need the goal hash and the dynamic collision hash. So what I might do is try drifting. Might pass in the ID. Like this. And does this use the goal hash or the collision hash at all? No, I don't think so. So the goal cell is just a hash of goal.floor. So basically, this, we also need the goal hash, the collision hash, like that. and we want to get the goal hash, and so we want to basically just do we just want to get a star search entry, I think. Return it as a copy. So this is a standard optional. Get a star search entry, and it returns the entry which has the path in it and the hashes and stuff. I'm going to go auto entry equals get a star search entry for the ID, and then if not entry, return EA star result unknown. We need to get rid of these expecteds. If we do have an entry, this is just entry full hash. There's no target index either. So we need the target index. What is target index? It's a standard optional to size T. So we kind of like need a set target index. We do target index reset, but that won't reset it because this is a copy. What's going on? For the goal, we're at the goal. We're about near the goal. We just return a vector towards the goal. Otherwise, to get the entry, if there isn't an entry, we can't do it. Start cell, end cell. We hash them. So if the goal is different, we reset the target. We reset the goal. If the goal is different, I think we just return standard unexpected. unknown. So I'm just going to say return standard unexpected. Here star result. Failed to find goal. Well, unknown because the goal changed from underneath us. Okay. If the dynamic colliders change, so I'm going to say if entry collision hash is not equal to hash, or just a hash 64 collider nodes, return unknown. If there's a target index and dmin is less than 2, or the dynamic collision hash is equal to the hash. So I think we're just going to say if dmin is less than 2, it's greater than 2. So if there's a target index, so if there's not a target index, we can't do it. We don't know where we're going. I'll put plus in though. This is complicated, man. This is so complicated. Because we're working our way through the target. So we just basically want an increment target index. So, you know, this could just return a reference, like an opt-ref. Because this is going to happen after a star is finished. So come along, we're going to go, if we're closer to the goal, if we're really close to the goal, we're at the goal. Otherwise, we just drift towards the goal. Otherwise, we get an entry. If there's no target index, we can't do anything. So presuming the target index is set by a star. Get the start cell and the goal cell. So that means the goal has changed. If the goal has changed, we can't do anything. Let me get the start cell, and we're looking for the minimum distance. And we're also hashing the collider, getting the collision hash there. So if the colliders have changed, we can't do the drift. And then we say if we're greater than 2, then we're going to walk. We're going to drift towards it. What was it for less than 2? If d min, what is d min? Oh, so that's the Manhattan distance. So we'll just say if d min is less than or equal to 2, we return unknown. So this target index here is entry target index. Reset the target index and we'll say we're at the goal. Get to being at the path count. Hang on. Otherwise, we just... So this is interesting. If we're less than, that means we're right about the node. So it's like 1, 2, or 1, 2. So rather than A star result, well, it could be at goal or unknown, yeah, I suppose. Because they could make an optional vector, but then we don't know why. Why we failed. Okay. Keep putting it in like that. Done it a bunch of places. There and there. So this is entry path. Entry path. Target index, target index, target index. And that's entry, target index, entry path. Entry, target index reset. Get A star search entry path. So I think we can just say this. So we're going to try drifting with the ID. So to be fair, that could happen immediately. So let's just see what happens. We need to set some data. We need to set some stuff in the entry. So first we'll just try drifting towards the goal. If we can't drift towards the goal, we'll kick off the search. So this needs to set a bunch of things. This needs to set the index and everything. Path index and everything. So we can't drift, right? There's not an entry. So we can't drift. The result is unknown. So we set it to working. And we're going to do some work. So I'm going to try drifting again. There is an entry and it's got path in it, look. We don't have the goal hash, the collision hash, or the target index though. So that needs to get filled in. So we're going to actually pass the A star here. This is A star, get path. Search entries index dot collision hash A star So this is the collision hash that the A star used, which we don't generate yet. So we're going to go so we might have a bit of a faster way to generate this collision hash. No, we need to do that. So the collision hash equals hash. How do we want to do this? What is the collision hash? Undefined at the moment. Dynamic collision hash. There it is. It's just hash. So I wonder if we could generate it a bit of a different way, right? We're going to go dynamic collision hash equals what is it? Hash seed. Where's the hash seed? Use default seed, right? Use default seed for U64, right? And then we're going to actually hash the position. P hash equals hash 32p. I'm just going to add the p hash in, and then what we're going to do, dynamic collision hash equals hash 64, just hash. So we want to pass a seed, which is the dynamic collision hash itself, and then p. Like that. And we'll generate the dynamic collision hash that way because that's faster. Because we're going to have to regenerate it in the drift bit as well. Okay, so what we want is U64 get dynamic collision hash. Turn the dynamic collision hash like that. So the dynamic collider nodes is what we use to see if we're in a collidable or not. But the hash is just the hash of all the dynamic colliders. So we're just passing the A star there now. So this is A star dot get dynamic collision hash. And the last thing we need is, well, we've got the goal hash. We need the goal hash as well. So we want U64, is that a U64? Goal hash. Get goal hash. I'm going to take these out. So we'll just say goal hash is equal to hash 64 goal cell. Like that. I mean, we may as well do that. We'll do that here. So this is the target index that we are setting. So we want standard optional get target index. And then what we want to do is we do target index.reset. Okay, good. So now, when we set the result, target index get target index like that. Okay, so this get path here needs to be standard span. Const. Like that. Okay. So let's run this and see what happens. So this drifting's a little mad. So we're going to go through it. We're going to try drifting there. We can drift there if we have performed an A* search before. And nothing about it. The goal hasn't changed and the dynamic colliders haven't changed. The dynamic colliders are the things that move in the level. If nothing moves in the level and the goal doesn't change, we can use the original path. We don't have to recreate the path because it'll just create the same path. But if the goal changes or the dynamic colliders change, so if the goal changes, which is this, so if there's not a target index, that means we haven't done an A* before. If the goal has changed, so let's look at this. If we're really close to the goal, we're at the goal. If we're really close to the goal but not close enough to be at the goal, we'll just move there. We don't have to do an A* search. That's like within one world unit. If we don't have an entry, meaning we've never done A* search before on this NPC, we can't do it. If there's no target index, that means A* has not been run before. we can't do it. If the goal has moved, we can't do it. I will recreate. One things we do need to do. We don't need this daemon stuff. We do need this daemon stuff. Is we recreate this hash a bit different now. So we do U64 din collider hash. Let's use default seed U64. Well, if we do we need the dynamic colliders? We don't need the dynamic colliders. That's why we took it out. So we don't have to actually have this array at all. So this. So we're going to do din collider hash equals hash din collider hash. And that will create the hash. So if the dynamic colliders have changed, we can't do it. So I have to use that din collider hash. If d is less than 2, we can't do it. I'm not sure about that. D min, what is D min? It's the Manhattan distance from the start to the end, from the start to P. P being from the colliders. If we're too close to a collider, we can't do it. That's what that's saying. Yeah, that's to stop us drifting into collidable zones. Otherwise, we just follow the path. That's what that's doing. We get to the goal, we get to the goal. Okay. So there's not even an entry. So we're going to come along, create one. And we'll either get here first or we'll get here first. So we got there first. So now we're going to set all of the stuff. Goal hash is 0. So we're not setting the goal hash there. Search entries index dot goal hash is equal to a star dot get goal hash. Okay, so we'll set all the stuff. So we do have our goal hash now. Target index is 1 in the path. So that's our target. That's where we want the character to move. So the next time we come around, we should be able to drift now. So the collision hash was not equal. So 823 was not equal. They were not equal. Because we're doing hash 32 there and hash 64 on the other one. I believe that's what it is. Just both hash 64. Okay, so now we should be able to do the drift. No, it's still not the same. Oh no, hang on. No, that is right. How are we doing the dynamic collision hash then? For the actual A star search internal. We're doing hash 32. Let's do the seed of U64. Okay, so let's just change them both to 64. That's fine. What's this? Okay, so it has to be 32 for both of them then. Fine, that's fine. Where are we? Hash 32. Okay, so this is in the A star search now. So we're starting off with 037 minus 4, 10. The dynamic collider is minus 4, minus 10. Oh. Well, okay, we could just hash P. That isn't a bad shout. Like, this is just hashing P, it's not hashing the hash. Do that then. All right. There we go. So the hashes are the same now. So the target index is 1. So we're going to get a D2, which is 1. And we're just going to move. So that returns a move position. All right. So let's just have a look then. Without any breakpoints. Okay, so now we're for some reason A starring all the time. Trying to A star all the time. So the drift's returning basically a really weird number at the goal. So we're at goal. So we're setting it to be unknown. The result is 0, 0 there. So that is weird IntelliSense, that. I think think we need to rebuild that. While this is building, I'm going to get a cup of coffee again. Coffee time. Be back soon. 2 minutes. All right. So we just need to wait for the guy to get to his goal. You can see he's working, flashing, and then this time is ticking, which means it's trying to do an A* search. All it should be doing is returning. So why is that return? It should be returning standard unexpected at goal. I don't know why IntelliSense is doing that. It's showing me it's just showing me scrambled data there. So if we're at the goal, so we can say else if result.error equals EA* result at goal. We can just return standard, well, just turn result basically. Which will kick off the next bit of pathfinding. But we actually need to set this to be unknown as well. Okay. Okay, so we're at the goal now. So we're going to set it to be unknown again. And then we're going to return it's at the goal. Which means the next time we come along, which will be when he wants to pick his pathfinding back up. Which is now. He'll try and drift. Return unknown, because it's a different goal now. and get the result. The result is unknown, so we'll set it to working. We'll try again with the new stuff, and it'll just repeat this. The question is, so this should just work now. It should just wander along, apart from when he's interrupted. There, see, he sat down for a second there, and it's because he went to be interrupted. What I need to do is turn off his combat. Oh, it is turned off. So what's going on there then? It's because I'm moving, because I'm a dynamic collider. Which means he needs to recalculate his pathfinding. So if I move, see there, he's going weird. So if I move, what's going on there? Basically, if I move, that means that this... So we only need to recalculate the path if I have moved into its path. Really? If I've moved into its path, so how do I detect that? We probably do need to build up an array. So I wonder if we were solving this before, because that kind of rings a bell. If you go to the unmodified version, what are we doing here? D-min. So it's the minimum distance between... yeah, so we're calculating the minimum distance between... We say start cell, which is where the guy is. And if it's less than 2, we recalculate the path. That's how this d-min comes into it. So that's actually and d-min is less than or equal to 2. So we only need to recalculate the path if we get right next to him. So if I move now, it's totally fine. It's only if I get right next to him. So let's draw the path back out again. So we have the entry. So we're going to go, this is temp code. So for auto p in path or entry, get path. We're just going to, so what is, this is vec2s. So we're just going to go canvas, game canvas, and then we're just going to go canvas.draw quad, draw bordered quad in world. The quad is rect p vec2 1 1. The stroke pixels to world 2. Color of the quad, we'll just say float color 1 0.2. Border color is float color 1 1. And the Z is in max. So we'll just draw some quads. This is just the path, and we're just going to see when the path gets recalculated. There we go, we recalculated it. It did sit down for a second. It sits down because for momentarily it returns an unknown or something. Which means it goes back to idle. The idle animation. So this might look better with an idle animation that is not so drastic. Oh, hang on. We can say if game state, get game state in current room, entry ID. We're going to draw these paths if we're actually in the room. We were drawing the Spidey path when we left the room then. Okay, don't know about game state. Include sci-fi gardener, game state. But it's good, it's working asynchronously. It's calculating the paths on the background thread now. Which is pretty good. Okay, so let's go to that other room. So I need to interrupt Jenny. I need to do this cutscene to interrupt climbing on that monorail because I can't catch up with the other eyes. Okay, so now she kind of stops. It did change the path though. So I think that's working. The only downside, of course, is if it automatically goes back to idle animation. Which means that the Spidey creature there ducks down for a second while the new path is calculated. Even though it doesn't take very long. taking hardly any time. This would work, you see, if we... There's no way that this job is completing before we get here, though. So if we don't run this job, is there an underscore run job? Just straight runs the job. There should definitely be an underscore run job. So I tend to use underscore run jobs to just immediately run the job on the same thread. Which is just basically job like that. All this means is it will do it all on the same thread again. So what will happen is if the path is interrupted and it's on the same thread, well, he'll still return working for a frame, which will make him sit down. If it's on the same thread, you could just return the result, you see. You could return the result of the A star search straight away here. If it's on the same thread. Which means he wouldn't sit down because he would probably have a result. By the time he needs to do his animation again, the new path will have been calculated. There's no real way to solve that other than have an idle animation. Have him sit there for longer than he needs to. Like basically sleep here for a second. So if you sleep for 1 second, which obviously like isn't great. Well, it just means he won't jerk. He'll do if you have to perform his act. He will give it if he has to calculate his pathfinding. He will stop for a second, which will look less weird than him just sitting down immediately. So if I go in front of him now, he sits down and then he does it again. Like that might be the way to do it. Just means obviously in combat it'll be stopping all the time. Now. No, he doesn't really. So what's going on there then? Like, why isn't he stopping? Killed me off there. Why isn't he stopping? Oh, because I think what's happening in combat is he's not using the Async version. So the movement controller. We're just using the normal A* search there. So if we did use the Async version, which is A* result, A* search, and all these arguments. Apart from it needs the ID. So in combat now he'll basically, every time he's performing his pathfinding, he will wait for a second, which will be rubbish. See, he's slower. I think he's slower. You weren't doing it. He was doing it on the nav mesh. He's not doing it on the. So this calls search internal. You know, I wonder what I should. I wonder if the best thing to do is, if they're not very far away, we just run A* search. So if the start and the goal are within, like, the Manhattan distance from the start to the goal is like within 5 units. I mean, that's no good really, because there might be stuff in the middle. You can imagine like the start and the goal being 1 meter away, but the path has to go, it's like a maze, it has to go all the way around. So let's just ignore the nav mesh version for now. He's constantly, because he's pausing for a minute. He's not able to put his attack in. It is nice with that sleep. See, it just doesn't work with the async version at all. Because he keeps going too idle. Basically what's happening is this is returning the way working. Is it? What's going on there then? Oh, I suppose I loaded the game then. That probably has to empty out all these. So is it even doing this? Unknown. So we could just say if the distance is within, like, if the distance is basically too long, we do an async one, and if it's not, if they're close to each other, we can do a synchronous one. What I want to know is why that is flickering like that. Ooh. I need to give myself loads of HP. What would it be under? Hero on spawn. No, maybe it's in combat stats. Nope. That's the tax and stuff. Where do I set HP for the hero? There we go. It's because it's sometimes Well, so what is causing that to happen? Because it looks like it's failing the find cover. There. It's not able to go back to set combat state. That's what's happening. So let's go to behavior actions. Find cover. What is it? Behavior types. Find cover. So it's because the move to. So it's going move to. And then that is coming down here and doing A* search, which is failing, which is setting the move target. So actually, it's we're going to go if A* result dot error is not equal to E A* result waiting working. Even do that. If it's still working, then fair enough. We haven't failed. We haven't ended the move. It's just still working at, still trying to work out the move. There we go, that stopped it. So is it still putting that sleep in? That's what I want to know. It's not. So what does it look like with that sleep in? I suppose we don't. The thing is, we don't want to do a sleep. We only want to do a sleep, I suppose, if the guy's not in a rush. If he's just wandering around the world. So there he's doing a little stop for a second. So we need, this sleep kind of needs to be conditional. You know, so we do a move to like this. When we do a move to, like when we do this, we need to get like a bit of a context, like why are we doing the A* search? Or even better, why are we doing the move? Why are we doing the move? And if we're in combat, we don't want to pause it. We don't want to do this sleep if we're in combat. here. Which does mean that this needs like kind of a think time. So it needs to have something like U32 think time or min think time. We can just pass it. If there's a min think time, sleep for it. And then in the movement controller, we'll put a minimum think time. We'll leave it at 0 for that. But in the NPC, in the game state NPC patrol stuff, tick patrol, tick NPC patrols. We want a min think time of 1,000 milliseconds. So obviously not all move to needs a minimum think time. It has 0. It's only the certain states where we need to do a minimum think time, combat being one of them. So we do need a move to context. Anyway, so this should fight me without doing any pauses. So here's the thing. That, where he's backing away, should be asynchronous. It is all asynchronous, I think. Yeah, there's no non-asynchronous A start. So where we do the A start, I think what I'm going to do is when we scope this timer here, we're just going to go if is main thread, VM is main thread. From the main thread, I'm going to log line I'll just log. Is there a log? Yeah. Main thread. Else log. Worker thread. So I can see which A stars have been done on the main thread and which A stars have been done on the worker thread. I think they're all being done on a worker thread at the moment. I think. Worker thread, yeah. So everything, including the backing off and stuff. So if I run away, hopefully he backs off without trying to attack me. There you go. That backing off one was on a worker thread because it's a long path to calculate that. So that took 6 milliseconds there, but it was on a background thread, so it was okay. Now it's back to normal, so it's doing its patrol pause thing. If we just turn off this tree again. We go up next to him. He sits down and then he recalculates, which is kind of what I want. I want him to sit down for a second. So that's what that thinking time is. Don't know if I do want that really. I do want him to just kind of seamlessly recreate the thread, recreate the path, sorry, without having to sit down. What that means really is he needs an idle. It's an animation thing really. He needs an idle that is like wait in kind of walking, which is maybe more of an implementation thing I won't have to worry about in the pathfinding. You know, to detect that, the animation routines for the roaming Spidium. It just says if the velocity is 0, we set it to idle. There and there. Now that's not necessarily true anymore. Well, it depends. We need what idle we want to set it to. Because if the velocity is 0, but because we're thinking about doing more pathfinding, that means in a couple of frames time, we're going to be pathfinding again. We're going to be walking again. So he's only going to sit down for like 2 frames or something. Yeah. It's super complicated, really. I think I want to take this minimum thinking time out. Which means you will go back to doing that sitting down for a minute, for like, well, not a minute, for like 1 frame or whatever it is. Just means the animation controller needs to know what is going on there. So we could, in the movement controller, not set the velocity. We could slow the velocity down. How does that work? Does this, is this type of thing? You just sit down for a second there. You can split. Sits down like for like 1 frame. So what I think I want to do is we will set the velocity to 0. I might do an EA here, put the EA star result here. Like this. Or we could have something like a movement controller specific one. Movement delay reason. Like here, movement context or something. Non thinking. And then we could have a movement, so movement text non. Movement context is thinking. And then when we tick, we're just going to set the movement context to be non. Like that. So it'll set it to thinking if the A star is. So we're going to say if the result is working, do it the other way around. We'll set it to be thinking. Like that. And then we can just do movement context, get movement context. This, that means in the animation routines now, we could be able to get a context, you know, if y the velocity is 0. Not in the hero one though. Spidey 1. So if last v is 0 and vel squared equals 0. Don't know why I need to do this. Let's just take that out a second and see if that screws anything up. I don't think we do need to do that. To be fair, I think it's probably thinking is a bad name for the context. It should be waiting on path finding. And in the animation routines, we can say if auto MC equals get game state, get movement controller for this rig. And the MC get movement context is equal to waiting on pathfinding. We'll play the idle alert. Animation instead. Oh, it's not in hero though. It's the wrong one. Spidey and roaming routine. So the idle alert has his tail up. Oh, we could pause. We could just pause the current animation. Still look weird though. We do need to do something about that. Or we could walk, you know, we could set the walk animation, you know. It gives us an opportunity now to set a different animation if we're waiting on pathfinding to complete. What does he do now? Did that even work? No. Okay, so that didn't work. So what's happening there then? Because the NPC patrol is not using the move tool. So that's going to go. Is it else if A star result error is equal to EA star result waiting working MC set move. Need to do the set movement context thing. Set movement context. Void set movement. You know, maybe we shouldn't do this. Maybe we should be actually asking the pathfinding itself. Because right now, this stuff's in. It's all free function stuff. We should make like a pathfinding controller or something, so we can just ask the pathfinding controller what's going on, rather than doing it through the movement controller. Or we could, yeah, maybe we don't even need to do that. Maybe we could do it through the movement controller, but the pathfinding sets the context. Yeah, that's better. So void set movement context. Movement context. Context like that. And then we take, we're not setting any contexts here. So that goes back here to not equals. That goes to there. And then the but the A star can't necessarily set the context. Dr. Elliot, how's it going? Hope you're alright. Just seeing your message. Sorry, wasn't looking at the chat window. Just working on, I'm moving pathfinding to a background worker threads. It's time. For so long I have kept it on the main game thread to keep me working on speeding it up. So, you know, when the pathfinding comes along and it slows down the main game thread, you notice. So I'm like, yeah, well, I best speed that up. But now we're at a point where I think it can go into the background. So we're just working that out. Particularly now, we're just going to like, how do you report to other gameplay systems that an NPC is waiting for a path to be built for it, so it can move along the path. Because the animation system kind of needs to know about that. If the character is walking along and then it needs to create a new path, and that path's going to take a long time, the animation system, right now it just default and go to the idle animation. But it would be nice for the animation system to know that the entity is waiting for a path to be made. Things are going all right, yeah. Just working through stuff. It's all working. Like the pathfinder is now working on the background, using you know, on a background thread. So this is like a different thread. This when it does run job. But we're just like, how do we set like, how do we tell the other gameplay systems that are now working on a path in a nice way? Yeah, it's going all right. I'm in deep thought mode at the moment, really. So I'm thinking right now, calling A star search from a bunch of places. I'm thinking we go through the movement controller and we say A star search, just pass in a goal. That's all we need to do. And then it gets the result of the A star search and it can set some context on what's happening. Yeah, that's good. So we'll try that. Let me just check in what we've got so far. If we can. Oh, save and commit. All of a sudden, GitHub is doing this. Every time I want to commit, it's asking me to choose. And it's like, I don't even know what that is, personal access token. I just want to know. I just want to always, you can't just like say, I'm always working on this. No idea. It means I've got to like press another 2 buttons to do a commit. And it does it for every repo. Like here it is back again because I'm committing to 2 repos. Ever since I updated Visual Studio, that's been doing that. Okay. So no one's calling set movement context. So this is going to happen. The set is going to happen from inside this class. So what we want is well, let's think. Game state. So we're calling A star search here, right? And we're trying to move to the destination position. I wonder if we could just do MC move to destination. Position like that. And not actually do this A star search. And we just eliminate where we do these. So this is if there's a nav mesh and stuff. So the source nav mesh. So all this stuff kind of needs to happen in the move to. So this move to can be moved to, you can move the player to anywhere in the room. This is like, you need to, this is a patrol, so we can give it an optional nav mesh to follow. If they're on the same nav mesh. So maybe we do another one called path 2. Well, no. Maybe we do have some kind of flags, you know, where we say like follow the nav meshes. So like enum, well, namespace, move to flags, enum value, none, and then we'll do use nav meshes. I'll try use nav meshes. Try using the nav mesh. Something like that. Is that correct? Yeah, BM enum flags. And then the move to we have a func there, which is what happens when we get to the target. So move to flags, and then wherever we're doing move to now, the whole word and case, which isn't many places. Do move to flags none there. 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 So what happens if you don't want to actually know? If you don't want a callback. Okay, well, let's just ignore that for a second. So this becomes quite a lot more complicated because we're going to have to now do all of the nav meshy stuff, which is probably fine. We do want a different move to, though, that doesn't have a callback in it. So you don't want to know. Let's just reset release or whatever it's called. And this just calls move to target max move speed flags and sets it. Sets the callback. So can you call this even if it's not set? No. Okay. Then the move to here. If after move to target. And we want E move to flags. Move to flags. None. That's basically here. These two go here. And this has its own A star now, which we're not using. So that can go. If the K stars, anyone calling this? It's calling it here, which we are going to remove. So this can go away. Oh, we do want a callback, look. Ooh, right. Okay, I'm gonna have 2 minutes to go to the loo, and then we should work on this. So it looks like we do need a callback because we can call back and do all this stuff. All right, won't be long. 2 minutes. Right. So it looks like we're going to need to basically get the context, the movement context out, and it's going to have to be similar to this stuff. So there's no A star or A star result. I think what all I'm going to do is if zero all this. Like this for now. So this changes. This is gonna go MC move to destination position, standard optional, float, flags, E move to flags, try use nav mesh, and then a callback. What's a callback look like? Right now it's just got a const standard optional reference. To the position where it ended up. There's no position. It didn't move there. Failed the move. So I wonder if we should actually pass the context over as well. So it would be E movement context. like that. So the thing about doing this is this is a one-shot thing. This is like you just move. You do this once and then it returns back, whereas this is more procedural, really. So this is going to have to basically go like, do the A star. And if it's working, it's already working on an A star doing this, can't add it in again. That's what this does. It goes A star, oh, it's already working on it. Which means the move to itself needs to check. Don't know really. That would be the best thing to do there. Maybe it would be better to do something like MC A star search destination position move 2 flags, try use nav mesh like that, and that returns an A star result. That didn't I? Yeah. And this goes back basically to how it was. A star flags, we'll call it. That means we need to get rid of all this stuff I've just put in. Just unfortunate. Not many though. Oops. That's what we're just messing about with now. Okay. So that's the A star result. So if there's an A star result, if there's an A star result, then we're going to move the player there. Else, if there's an error, we just set it there. For that goal, we advance the patrol. The bonus with doing this rather than doing the A star right here is that we can set I don't know really. Alright, let's just go back. Let's go back. Oops. Let's wait for Visual Studio to catch up. If we use A star through the movement controller, we can set the context of the move, whether it's waiting or not. So what's doing here? What's happening here? We're ticking. So if there's a move target, we have to come along. And then we're doing it here anyway. So I do think we want an A star search. That moves along the A star search. So we could do A star search 2, which will move the guy along. And then it can return the result of the A star search. And if we're at the goal, we can advance the patrol. Maybe that's how it happens. All this MC set position. So what's happening there? We're advancing a patrol 2 times. So this is if there's a result. And we're intersecting the destination position. That's when we get to our goal, basically. I think. So I wonder if we need to do this. Like if we're at the goal, we just advance the patrol. If we can knock this out, then we can do basically NP movement controller A star search. That returns the A star result. If the result is at the goal, we advance the patrol, and that's it. As long as we don't have to, we've got two. Not, I wonder why we're doing that there. As long as he stands up. There we go. So I don't think we do need that there. So we just do MC tick. So that moves the character. This is obviously DT2. Don't want to move the character if the game's paused. Like, I've been wanting to clean this code up for a while, so this is good opportunity, really. Okay, so I've got a couple more minutes. I'm just going to set this up in the movement controller now. So we want A star result, or even better, E A star result. A star move, whatever. A star move, and we just need the destination position. Like that. And then this is that's gonna perform all this. Oops. That's gonna do all this stuff where it's moving the character, getting together the nav meshes, all that stuff. So we need the level. So we want auto level equals get game state, get current level. If not level, return EA star result. Fail to find goal. We want to do this stuff. Whoops. So this is position, which is location position. And the dest position. So I might do auto source P equals location dot position like that. I have a source P and a dest P. And then this is the collision hashes for the animated rig. So this is location room. We want the animated rig type. This is ID. So that gets the collision hashes. And then we're going to go if source nav mesh is equal to the dest nav mesh. To do, whoops, a star with a nav mesh, which you haven't got yet in the async term. Else we do a star empty, and then we're going to do a star dot search ID, get interaction bounds. Whoops. Dest P. Current region bounds. So we want to get the current region. Get game state. Get current region. Dot bounds. We kind of need the room that this entity is in, though. So this is like region location. So we need to get the room. Room bounds plus level, get room bounds for the location dot room. This is the room bounds that we're in. Collision hashes, and then we want to generate the dynamic colliders for the ID. Basically, we just want to return, well, auto result is that. If result.error, well, if not result, return result.error. So it's going to be something like that. Else, if there is a result, we got to move we got to do this. So I don't think we're returning a star result, actually. That's me, I've got to go. We don't want to return an here, not an EA star result, but a movement crawler result of some kind. So this is basically this section here. We just set the position. If you couldn't find the goal, the start is in the collidable. But this has to return something else. So if we couldn't find the goal, what do we want to do? What do we want to do? And then basically this is going to call it. So auto move result equals MC a star move destination position if move result is at the goal, we advance the patrol. And that basically all goes away. That's basically it. Oh. What's going on here? So we just say, the time's not running anyway, do the A star move. If the move result is at the goal, we advance the patrol. And the A star move is responsible for basically calling tick on the movement controller. So this should be called A star tick or something. Okay, I'm gonna have to head off. 3:15. Get my kid from school. I'll be back on tomorrow though. About 9:30 in the morning.